Hello everyone, welcome to My Math Teacher. In this video, I am going to solve question numbers 4 to 7 from the exercise 1.3. This is for class 9 students. Chapter is real numbers from NCERT syllabus. Question number 4 here is express 0.999. The 9 is repeating here in the form of P by Q. Are you surprised by your answer? This is again we have to solve like the previous sum. So let us start doing this. Now let us take this given decimal form, that is let x is equal to 0.9 keeps on repeating here. Let us take this as equation number 1. Multiply by 10 on both sides. Why we are multiplying by 10? Because this is the only number 9 which is keep on repeating. So we have to multiply by 10. Now it will be 10x which is equal to the decimal will shift to this place, that is 9.999. It will be like this. Let us consider this as equation number 2. Now subtract equation 2 minus equation 1. So write the equation number 2 and below that we'll subtract 1. Now when we do the actual subtraction, as you know, when you subtract it, everything on the right side becomes 0. So before the decimal, 9 minus 0 is 9 here, which is equal to 10x minus x is 9x. So we have 9x is equal to 9. X is equal to 9 divided by 9. X value is 1. So you can see this. X value 0.999 which is recurring here is equal to 1. How it is possible? Because as you can see 0.9 the number keeps on repeating. You can write n number of 9s here. So after completing the next immediate number after this will be 1. So we can say that this number is too close to number 1. Therefore, we can say that is equal to number 1. Question number 5. What can the maximum number of digits be in the repeating block of the digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Here what we have to do is we have to divide 1 by 17, and if you are keep on dividing you will have a repeating pattern. After how many digits that repeating pattern occurs? That is the question. Simple. Now I am dividing 1 by 17, 1 here by 17. So when you divide 1, you can't divide by 17. Add 1 0, place the decimal here. Again 10 is less than 17, add the next 0 and include the 0 here. So now you can see 17 multiplied by 5 is 85. So I kept doing the entire division. As you can see, this is a very lengthy division. I had to continue the division here as well. So at one point of time you can notice here 120 minus 119 where I got the remainder as 1. So again when you divide 1 by 17, the same as the first step. You can't divide, add 1 0, so that 0 is added here, again 0, the same as the first step. So when I counted the actual digits after the decimal, it was total 16 here. So 0 to the 7, it was total 16 digits. After again 0 appeared. So as you know, from this point you have to continue the division again. So what is the answer? The maximum number of digits in the repeating block of the division 1 by 17 is 16. So total 16 digits. After 16 digits we have the repeating pattern. Question number 6. Look at several examples of rational numbers in the form P by Q where P and Q are integers with no common factors. So this is important, other than 1, and having terminating decimal expansion. Can you guess what property Q must satisfy? Let me explain this by giving examples. That is the first example. Let us take this number, that is 2 by 5. Okay, first you notice here these two numbers, that is P and Q, they have only 1 as the common factor. That is very important. That should be only 1 as the common factor. Now you have to study about the denominator, that is Q. Do the prime factorization. 5 you can divide only by 5. Now 2 divided by 5, as you can see when you do the actual division, it is 0.4. Terminating decimal expansion, yes. No common factors other than 1, yes. So both the conditions have satisfied with our example. Now let us study the property of Q. So what is Q? When you do the prime factorization, we have only 5. So just keep it as it is, 2 by 5. Okay. Now the second example, let us take one more example. So take this number 3 by 100. You can see, check the first condition, there is only 1 as the common factor. Other than that, there is no common factor. Now, is it terminating? Yes, because 3 divided by 100 gives 0.03. This is terminating. Now, we'll check the property of Q. So, what is Q? 100. Do the prime factorization. 2, 50, again 2, 25, 5, 1. This is the prime factorization. Now 3 by 100 can be written as 2 square into 5 square. Am I right? So we are studying the property of Q. Now the third example. This is given in the exercise. We'll take the same one, 33 by 8, which is, when you divide this, you will get the answer as 4.125, which is terminating. Now you notice here there is only 1 as the common factor. It is terminating decimal expansion. Yes. Now 8, do the prime factorization. Yes, 8 can be written as 2Q. In all the 3 examples, observe the denominator, which is Q, where we have done the prime factorization. Here it's only 5, 2 square into 5 square, and here 2 cube. So what does this indicate? So Q indicates that Q has only powers of 5, powers of 2, or both. So this is the indication we get about the property of Q. So Q is in the form of powers of 2, powers of 5, or both. So you can finally give your answer like this. Q is of the form of powers of 2, powers of 5, or both. So Q is of the form 2 power m into 5 power n. The last one, question number 7. Write 3 numbers whose decimal expansion are non-terminating and non-recurring. So non-terminating and non-repeating. So irrational number side, you will definitely remember root 2 value, root 3 value, and you can include pi value also. So you have to write any 3. So let us start from root 2. So root 2 is 1.4142. It keeps on repeating. So these are the easy numbers to remember. That's the reason I am choosing these numbers. Root 3 is like this. So you can write pi as well, which is 3.1415. It keeps on. These are the 3 easy examples which you can give for non-terminating and non-recurring numbers. I hope you must have understood all these sums which I have taught today. See you in the next video. Until then, take care, bye, keep practicing, and subscribe to my math teacher.